Hello, good afternoon students, how are you? Welcome to one more fabulous session from Infinity Learn by Sri Chaitanya. मैं हूँ सुरेश, faculty of chemistry from Infinity Learn by Sri Chaitanya. We are in NEET Step Up 2025 program. Welcome to the session. How are you my dear students? Himanshu, Ravindra Reddy, happy afternoon. Great to see you guys. Today we are going to close solutions and colligative properties. Good afternoon, Ishita. Yesterday I couldn't see you. Himanshu, I couldn't see you. Ishita, what happened yesterday, beta? So be regular in the class, right? Very good. So what happened? You tell me, Ishita. May I know the reason? So you are the one who are regularly present in the class. Okay, that's good. Hello Himanshu, good afternoon. Good afternoon. In this sessions of solutions and colligative properties in NEET Step Up 2025 program, in a week, first 3 days we will be discussing about 11th standard concept that we completed, alkanes. Okay, and next 3 days we are in 12th chemistry, we are in solutions and colligative properties. In this, okay, you are a hosteler, okay, right, hello, okay, Sri Chaitanya school, okay, very good. You can see the recordings of the class, Ravindra Reddy, okay, no issues. Okay, when is your reopening day, Ravindra? When is your reopening? Okay, in this last 3 days we are talking about solutions. In this we talk about types of solutions, concentration terms, solubility, solubility of solids in liquids, solubility of gases in liquids. We talk about Henry's law. So these are the topics that we discussed. Okay, so total plan of solutions and colligative properties is like this. Abdul Rahman, hi, good afternoon. So we discussed types of solutions, methods of expression concentration terms like molality, molarity, mole fraction, percentage, ppm and other relations among them, molarity and molality के बीच में, molality and mole fraction के बीच में. Okay, so 12th is reopening day and you can ask your friends to continue the classes, right? And you can also see the recordings of the classes when you are free. However, in the hostel you will be having some leisure time, right? Hi. Okay. So yesterday we discussed about vapor pressure. What is vapor pressure? And also Raoult law we completed, and ideal solutions, non-ideal solutions. In that, positive deviation, negative deviation also we completed azeotropic mixture. So in the last day for this week we will be discussing about colligative properties in abnormal molecular mass. Okay, this is the plan for today's lecture. So moving ahead, in the vapor pressure we discussed everything. Okay, vapor pressure curves and about temperature dependence. Yeah, I know that mobiles are not allowed. Temperature dependence of the vapor pressure, Clausius and Clapeyron equation. And hi Miss Smita, hi. Be regular dear Smita, you are there long ago and after that I can see today. So I request you to be regular in the class, right? And we discussed about what is boiling point. So this is a short recapture about the vapor pressure and all. So these things which is completed in the previous sessions. So we will be discussing about, so this is about liquid solution. For the liquid solution we have Raoult law, and about Raoult law ideal solution, Dangli, and hi Nirmala, hi, hello Nirmala Acharya from Dang. Okay, so Dang is a place, Okay, so today's class we will discuss about, so this is a solution which behaves as an ideal. So ideal solution graph. So ideal solution, in order to say a solution to be ideal, what are the prerequisite condition? It should obey this graph. And what are the other conditions? You want me to give a short recap of the vapor pressure? So when you talk about, so ideal solution is a solution which obeys a tuition. You can just go through the recording if possible, Ishita. Okay, so relative lowering of vapor pressure we discuss in today's class, and we'll do some numericals based on that also, Ravinder. Okay, talking about ideal solution. Ideal solution is a solution which obey Raoult law at all concentrations, right? So for that, intermolecular forces are the key point. So when a liquid A and liquid B are mixed, before mixing there is an attraction between liquid A molecule to liquid A molecule and liquid B molecule to liquid B molecule, right? So intermolecular forces A and B and B. When you mix and forms a homogeneous mixture between A and B, so A and B बीच में intermolecular forces शुरू होगा. So I watched your recording lecture due to some network issues. I want okay, not an issue. Okay, if you are able to attend the regular live class, ये अच्छा बात होगा क्योंकि लाइव चैटिंग में हम डिस्कस कर सकते हैं. अगर नहीं हो पाएगा तो आप रिकॉर्डिंग भी देख सकते हैं, है ना. Infinity meta, right? So these intermolecular forces, the magnitude बराबर होगा. यही है पहला कंडीशन. ये सॉल्यूशन आइडियल बोलने के लिए यही पहला कंडीशन है ना. सो जब आप ये सॉल्यूशन ए एंड बी और मिक्स ना, वी मिक्स इज गोइंग टू बी जीरो. सो कुंभार एग्जांपल्स ऑफ आइडियल सॉल्यूशन आई विल गिव इन द नेक्स्ट स्लाइड. ओके, सो व्हाट इज वी मिक्स इज जीरो. अगर आप 50 मिलीलीटर्स, सीएम क्यूब का मतलब क्या, मिलीलीटर्स है ना. For example, when 50 milliliters of a benzene and 50 milliliters of a toluene are mixed, so you are going to get exactly 100 milliliters of the solution. अरे when 50 milliliter mix होगा तो आपका मैथमेटिकली 100 ही मिल जाएगा. लेकिन व्हेन यू गो फॉर ए नॉन आइडियल सॉल्यूशन, जो भी सॉल्यूशन लैबोरेटरी में आप प्रिपेयर करना चाहता हूँ, मोस्टली दे आर नॉन आइडियल सॉल्यूशंस. इफ़ यू मिक्स 50.00 मिलीलीटर 50.00 मिलीलीटर, यू मे गेट 100.01 मिलीलीटर. है सच बात है. और 99.98 मिलीलीटर, वी डोंट नो. सो द वॉल्यूम कैन बी डिक्रीज्ड और द वॉल्यूम कैन बी इंक्रीज्ड. लेकिन सिर्फ आइडियल सॉल्यूशन का वॉल्यूम हमेशा बराबर होता है. सो इस तरफ अच्छा तरफ आपका लेक्चर चाहिए तो, सो माय डियर स्टूडेंट्स, आई सजेस्ट ऑल यू गाइस प्लीज लाइक दिस सेशन सो दैट यूट्यूब अल्गोरिदम के हिसाब से हमारा जो इन्फिनिटी लर्न का ये वीडियो प्रमोशन में अच्छा तरफ हो जाएगा. सो पैसा कमाना क्या नहीं कर रहे हैं, प्रमोशन करने का कर रहे हैं. इसीलिए हम हमेशा बोल रहे हैं लाइक एंड शेयर एंड सब्सक्राइब. समझे? ओके. सो वेपर प्रेशर क्या हो रहा है. सो वेपर प्रेशर का बारे में बात कर रहा हूँ कुंभार, राइट, आइडियल सॉल्यूशन का. सो आइडियल सॉल्यूशन का जो वेपर प्रेशर है ना, द सम ऑफ द वेपर प्रेशर इज गोइंग टू बी सेम. ओके, सो हियर if you talk about a few examples, आप पूछ रहे थे ना इसका एग्जाम्पल क्या, एग्जाम्पल क्या, यही है एग्जाम्पल. सो बेंजीन एंड टोलिन एंड एन-हेक्सेन एंड हेप्टेन एंड इथाइल ब्रोमाइड एंड इथाइल क्लोराइड. और एक एग्जाम्पल है बेटा, दैट्स गुड कुंभार, धनंजय कुंभार, राइट, ग्रेट. क्लोरोबेंजीन एंड ब्रोमोबेंजीन. सर हमको कैसा पता चलेगा उसमें कौन सा इंटरमॉलिक्यूलर फोर्स चल रहा है. सो ये बात इंटरमॉलिक्यूलर फोर्स कहाँ दिया, एनसीईआरटी टेक्स्ट बुक में और किसी स्टूडेंट बोलने तो मेरे को अच्छा लगेगा। इंटरमॉलिक्यूलर फोर्स जो कॉन्सेप्ट है एनसीईआरटी टेक्स्ट बुक में दिया गया है ना। हाँ, yes, that's good, Ravinder. You said I have seen that. Okay, NH10, NH10, all in the chart record I can see. I can see only the chart record on the screen in front of me and a camera and my world. This is my world. Okay, my board is my world as a teacher, and here it is my student community. We are raising a better result in NEET 2025. So I am giving you promise, you also give the same oath. Definitely we rise together and अब सब लोग को भला होगा बेटा। राउल्स लॉ, सो यू वांट मी टू टेल अबाउट राउल्स लॉ? वो राउल्स लॉ है ना, ओके, डेफिनेटली आई विल टेल यू। ओके, या, so Raoult law is Dhananjay Kumbar requested me about Raoult law. As this concept is completely completed yesterday, so request given by Dhananjay Kumar, I just want to discuss about Raoult law. Okay, for everybody is fine, right? So Raoult law, ये राउल्ट लॉ समझाने के लिए सिर्फ आपका थोड़ा सा एक्सपेरिमेंट चाहिए। ओके, सो व्हाट इज दिस? दिस इज ए लिक्विड ए एंड दिस इज ए लिक्विड बी। सो लिक्विड ए लिक्विड बी आपका थोड़ा सा अंडरस्टैंड करने के लिए मैं अलग अलग रंग दिखाना चाहता हूं। सो लेट दिस इज क्लोज्ड, lid is closed. So I just want to take liquid A in a green dot. Liquid A evaporate करने के बाद, so this liquid is going to evaporate. So these are the vapors of liquid A. This vapor of liquid A, when they come back, they make some kind of force when they hit on their own liquid at equilibrium. That is called equilibrium vapor pressure. That is the definition of vapor pressure. The lover of art. Very good. Nice names. Okay, right. Talking about when this liquid hit on its own surface of the liquid, it exerts some force on its liquid surface. That force per unit area is called pressure. That is what you call it as vapor pressure of A. So P naught A says vapor pressure of pure A, pure component liquid A. समझे? Any doubt? Dhananjay, for you I am just tearing my vocal cord and I am discussing the things, so सबको अच्छा होगा, right beta? Liquid B, I just want to use liquid B as a blue color. So this liquid B again evaporate. So it is going to be the vapors of liquid B. This liquid B causes pressure on it. Okay, so that it is going to be vapor pressure of pure liquid B. समझे? Vapor pressure of pure liquid B. Now what I want to do, I just want to mix these two, so that ये अलग कंटेनर में ऐसा रखना है ना? Ravinder, you said correct. P naught A dot mole fraction of A plus P naught B dot mole fraction of B. So in that you have liquid A mixture, you have liquid B also, and this is a solution, homogeneous solution. In this solution you have A is in the liquid state, it is also evaporate, and B is also there in the solution, so the B is also evaporating. Now this is the vapor, it also causes pressure, है ना, that is called vapor pressure of the solution. In this I just want to say here, this indicates PA, this indicates what is PA. PA is partial vapor pressure of component A, component B in solution. जब सॉल्यूशन में होगा तो पी ए एंड पी बी बोलना है. ये होगा आपका color denomination. If you understand, that gives, both are volatile, both are volatile. Volatile means they can evaporate, non-volatile means they cannot evaporate, है ना. So this is PB. So PB है vapor pressure, this is PA ना, this is PA. PA stands for vapor pressure of BA in solution. Green is A and blue is B. Okay, don't worry about that. So what Raoult law says now? Raoult law says अगर आपका ये ग्रीन डॉट लिक्विड में ज्यादा होगा, वेपर में भी ज्यादा होगा. So I just want to say PA is directly proportional to, ज्यादा होगा कम होगा के बोलने का आप मेजरमेंट चाहिए, मेजरमेंट कॉन्सेंट्रेशन का हिसाब से मोल फ्रैक्शन लेना चाहता हूं. He is directly proportional to mole fraction of A, so that it is equal to PA is equal to P naught A upon mole fraction of A. So ये हमेशा कांस्टेंट होता है, लेकिन ये वेरिएबल होता है क्योंकि ये मिक्सचर प्रोपोर्शन के हिसाब से डिपेंड करते हैं. लेकिन ये प्योर स्टेट है ना, प्योर स्टेट जब तक टेम्परेचर कांस्टेंट है ये वैल्यू हमेशा कांस्टेंट है बेटा. धनंजय कुमार, ओके, कुंभार, राइट. होप यू आर अंडरस्टैंडिंग. क्लियर, क्लियर बेटा. अरे एक थम्स अप इमोजी डालना यार चार्ट बॉक्स में. ओके, सो आई जस्ट वांट टू टॉक अबाउट, यस, PB is directly proportional to mole fraction of B. PB is equal to P naught B mole fraction of B. So this ये चीज जो है ना, ये वाला राउल्ट लॉ है, राउल्ट लॉ है. Partial vapor pressure of a component in a solution is directly proportional to its mole fraction in the solution, right? That is the actual definition of the Raoult law. मेरा आवाज सुन रहे हैं क्या? हाँ. So अगर आप ये डाल्टन क्या बोले, डाल्टन बोल रहे थे P टोटल इज इक्वल टू P1 प्लस PB P2. ये वाला 1 है, वाला 2 है, ये B. सो ये सॉल्यूशन का आता है टोटल सॉल्यूशन वेपर प्रेशर इज इक्वल टू PA प्लस PB. आप बोल सकते हैं PS इज इक्वल टू P नॉट A मोल फ्रैक्शन ऑफ A. रविंद्र रेड्डी बोला, ओके, P नॉट B मोल फ्रैक्शन ऑफ B. समझे बेटा? These are all, this is actually the main course of the Raoult law. Clear है ना? Any doubt my dear students? All right, okay, let's go ahead, आगे बढ़ो. वो बोल रहे हैं, सो जो if you talk about PA mole fraction of A, it said that PA is directly proportional to mole fraction of A. Therefore, it goes like this. Similarly, we say PB is directly proportional to mole fraction of B. So, if I say Pb mole fraction of B, ग्राफ देखने के Pa मोल फ्रैक्शन ऑफ ए ऐसा देखना, Pb मोल फ्रैक्शन ऑफ B ऐसे देखना. Got it? So it comes to be like this, है ना? So when these two are connected, that is going to be Ps is equal to Pa plus Pb. This is a graph for ideal solution. Got it? This is a graph for ideal solution. आगे बढ़ो. फॉर आइडियल सोल्यूशन हमेशा देखना, ख्याल में रखो, इंटरमॉलिक्यूलर फोर्स ये बीच में, बी बीच में, ये भी बीच में बराबर होना चाहिए. सो दैट एंड आल्सो एंथैल्पी ऑफ मिक्सिंग इज जीरो and enthalpy of mixing is 0 and enthalpy of volume is 0. So change in the volume is 0. This is about Raoult's law. Okay, so that is V mix is 0. Is that fine? Dhananjay, it is for you. I recapped what is Raoult's law. Fine beta? Fine beta? Richa Sharma, hi, how are you? Yesterday and day before yesterday. Yesterday you are not there in the class. Why? May I know the reason? Richa, you are one of the regular student. Dhananjay Kumbar, tell me, hope you understood, right? Yes. So these are the examples. So to understand better, how do we know these examples रटा मारना है क्या? नहीं, बिल्कुल नहीं. उसमें इंटरमॉलिक्यूलर फोर्स का स्टेटस एक बार देखने तो आपको पता चलेगा ये कैसा आ रहा है. ओके, सो इंटरमॉलिक्यूलर फोर्सेस, लंडन डिस्पर्शन फोर्स, आयन डाइपोल फोर्स, डाइपोल फोर्स, इंड्यूस्ड डाइपोल फोर्स and hydrogen bonding. These intermolecular forces are presented in the NCERT states of matter in the first page. You can see and you can learn it. Of course, these intermolecular force again I am going to discuss when I talk about the states of matter. Mind it? Okay. Let's see non-ideal solutions. जो solutions है ना, those solutions which do not follow, do not obey Raoult law are called non-ideal solution. Therefore, V mix is not 0, H mix is not 0. है ना? If it is not equal means it can be less or it could be more. So that is explained by positive deviation or negative deviation. Let us talk about a non-ideal solution. In this non-ideal solution, everything is not equal, right? So ideal solution means it is equal, right? So I am going to give you the best way to classify this. Negative deviation. I just want to say negative deviation and a positive deviation. What is the key point to say ideal and non-ideal? Sirf intermolecular force. If you are good at intermolecular force, you can do the best in understanding. Okay, I will show you. So what is this? Intermolecular force. For positive deviation, intermolecular force between A and B and A. So intermolecular force between A and B is going to be less. I will tell you from there. You can see intermolecular force between A and B and B and B and A and B. Intermolecular force here it is going to be less. Here it is going to be less. Okay. So, if it is less, what happen? Say an example. First, we will take an example. In negative deviation or positive deviation, Ravindra Reddy, do not obey Raoult law. Okay. Yes, of course, both do not obey Raoult law. What you said is correct. Okay. So, मैं आपका एक एग्जाम्पल देना चाहता हूं. एग्जाम्पल, वाटर प्लस इथेनॉल, वाटर प्लस इथेनॉल, ये अंडरस्टैंडिंग लेवल शुड बी देयर फ्रॉम द एग्जाम्पल itself, C2H5OH and water. So what happen if water, hydrogen, oxygen and hydrogen, hydrogen, oxygen and hydrogen, वाटर मॉलिक्यूल बीच में क्या होगा? आशिक आशु, हाय, गुड आफ्टरनून. सो बीच में आपका हाइड्रोजन बॉन्ड होगा, है ना, हाइड्रोजन बॉन्ड. सो दिस हाइड्रोजन बॉन्ड, केयरफुली यू ऑब्जर्व दैट हाइड्रोजन बॉन्ड आपको दिखाई दे रहे हैं, हाइड्रोजन बॉन्ड दिखाई दे रहे हैं. When water, everybody knows hydrogen bond is there. Good afternoon, Ayush Gupta. Okay, हाँ, हाइड्रोजन बॉन्डिंग. अगर वाटर मॉलिक्यूल से इथाइल अल्कोहल ऐड करना चाहता हूं, इथाइल अल्कोहल जो है, इथाइल C2H5OH, दिस इज द स्ट्रक्चर ऑफ इथाइल अल्कोहल, है ना. दिस इथाइल अल्कोहल, this ethyl group is hydrocarbon part. So this hydrocarbon part is hydrophilic or hydrophobic? Hydrophobic. So ये water को repel करता है, ये ethyl group water को repel करता है. So जब ethyl alcohol water में add करेंगे तो क्या होगा? ये ethyl group वाटर मॉलिक्यूल बीच में घुसना का कोशिश करता है. इसी का कारण व्हाट हैपन, वाटर मॉलिक्यूल्स आर सेपरेटेड, हाइड्रोजन बॉन्ड तोड़ देंगे मैं. अंडरस्टैंड? सो ड्यू टू हाइड्रोफोबिक नेचर ऑफ इथाइल ग्रुप, हाइड्रोजन बॉन्डिंग इज ब्रोकन. yes. Okay, for positive deviation and negative deviation you have given that. So use other color. Hydrogen bonding, Ishita. Yes, for hydrogen bonding, I just want to use this color. Fine, this color. Fine. Now is that visible? Right. So that these two are mixed, hydrogen bonding is broken, so that interaction between A and B, intermolecular force कम आ रहा है. Got it? That's great. So when the intermolecular forces are decreased, liquid molecule do not make great attraction, so that they have a great tendency to evaporate. So vapor pressure बढ़ जाएगा. Therefore what happen, if you see the ideal solution का behavior, PA mole fraction of A, PA PB mole fraction of B, what I am expecting here, if it is an ideal solution, this is the behavior for ideal solution, है ना. लेकिन यहाँ पर वेपर प्रेशर बढ़ रहा है, so that vapor pressure is coming like this. Are you getting or not? This is the reason. Yes, you got a doubt in azeotropic mixture. We are getting in the next slides, Ravinder. Okay, now मैं क्या बोल रहा हूँ, PA is greater than P naught A mole fraction of A. Similarly, Pb is greater than P naught B mole fraction of B. So Ps is greater than Pa plus Pb. So these are the conditions. When the molecules are separated apart, its volume is increased. Delta V mix is greater than 0 and delta H mix is going to be greater than 0. As the old hydrogen bonds are broken, energy is released. Are you getting or not? Now, आयुष गुप्ता, डेफिनेटली. और एक एग्जाम्पल देना चाहता हूं इसका नेगेटिव डिविएशन का. ये नेगेटिव डिविएशन का आपका एग्जाम्पल है एसीटोन प्लस क्लोरोफॉर्म. एसीटोन एंड क्लोरोफॉर्म. जो एसीटोन आपका स्ट्रक्चर देखना पड़ता, CH3 C डबल बॉन्ड O एंड CH3, उसमें कुछ हाइड्रोजन बॉन्डिंग वगैरह नहीं होता है. एंड क्लोरोफॉर्म का स्ट्रक्चर है CHCl3. सो HCl CCl Cl Cl. तब जब आप यू आर एडिंग दीज टू ना, so what happen? A new hydrogen bonding is introduced. New hydrogen bonding is introduced, so like this. So नया hydrogen bonding अभी introduce किया जाएगा, so that when A and B are mixed, इसका hydrogen bonding का वजह से intermolecular force बढ़ रहा है. Yes, you can take that example, इशिता. So जब intermolecular force बढ़ रहा है, इंटरमोलिकुलर फोर्स कम आ रहा है, वेपर प्रेशर बढ़ रहा है. सो इंटरमोलिकुलर फोर्स बढ़ रहा है, वेपर प्रेशर क्या होगा? यू टेल मी आयुषी, यू टेल मी व्हाट विल हैपन? आयुष गुप्ता, इसका वजह से बोलना. यस, इट इज गोइंग टू, वेपर प्रेशर इज गोइंग टू कम डाउन, वेपर प्रेशर कम होगा. सो दैट if you talk a graph between Pa and mole fraction of A, Pb mole fraction of B, so it is going to be, if it is an ideal solution, the behavior is like this. अगर ये solution ideal होगा तो ऐसा होगा, लेकिन ये नेगेटिव डिविएशन में इंटरमोलिकुलर फोर्सेस का वजह से वेपर प्रेशर कम आ रहा है. हाँ 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 आयुष, फाइन. यस, इट इज लो. यस, I don't know बेटा, it is near about 4 lakhs, 4 to 5 lakhs. So as the vapor pressure is coming down, it is, the graph is below the expected. Okay, graph is below the expected, graph is below the expected. So this is a negative deviation beta and this is a positive deviation beta. So what happened? Pa is less than P naught A mole fraction of A, Pb is less than P naught B mole fraction of B, and Ps is less than Pa plus Pb. And enthalpy of and volume of mixing, when the solution particles due to hydrogen bond का वजह से they are coming close, right? Therefore the volume of the resultant solution decreases, less than 0, enthalpy of mixing is less than 0. So this is the overall picture about non-ideal solutions. ठीक है? Any doubt? Any doubt here? You don't have to memorize any kind of examples. If you memorize it, that's fine. You don't have to memorize, because if you find intermolecular force, how it is happening, and if you have a good knowledge on intermolecular force, you can do the best. समझे बेटा? Take a snapshot. Oh, that's good, Ayush Gupta. Thank you very much. 1 minute. Right. Now, this is the best way to understand, this is the best way to memorize as well. If you want to go for any thing, it is going to be like this only. Okay, right. So, acetone and carbon disulfide, CS2 is an example for the positive deviation. Acetone ethyl alcohol, acetone benzene, methyl alcohol and water. Okay. And ethyl alcohol and water, carbon tetrachloride and chloroform, and carbon tetrachloride and benzene, and carbon tetrachloride and toluene are the best examples. So, whenever intermolecular forces are disrupted, you will have a positive deviation. Whenever intermolecular forces, new intermolecular forces are established, you will get negative deviation. So, this is about the negative deviation, the graph that I drawn here. So, non-ideal solution showing negative deviation, these are the some more examples. Okay, we will look into the examples here. Yes, chloroform and benzene is an example, and chloroform and diethyl ether an example, acetone and aniline, phenol and aniline you can also take. इसी तरह आपका जो example है, okay, so HCl and water, HNO3 and water, and acetic acid and pyridine. What is pyridine, beta? What is pyridine? Pyridine is extensively used in organic chemistry. इसका structure आता है ऐसे. This is a pyridine, it is actually acting as a base and as well as solvent. ठीक है? हाँ हाँ ना C5 नहीं. That is pyrrole. Next, we are talking about pyrrole. Is okay, right? That's correct. Now, minimum boiling azeotrope and azeotrope. I am talking about azeotropic mixture or azeotropic mixture or azeotrope. So, this is actually not that great important as far as the NEET examination is concerned, and this may be useful for IIT, but NEET के इतना काफ़ी important नहीं है, लेकिन ये वाला थोड़ा सा इंट्रोड्यूस करके ख़त्म करना चाहता हूँ मैं. Okay, so azeotropic mixture means a mixture of two liquids boiled together. When liquid A and liquid B, okay, when a liquid A and liquid B are mixed and you want to boil, so A is going to boil than B if boiling point of A is less than B. So, one is boiled, later the other one going to boil, but this mixture boiled together. So, this is your doubt. These mixture boiled together at certain proportion, so that इसका मोल फ्रैक्शन जो है ना लिक्विड स्टेट में एंड वेपर स्टेट में दोनों बराबर होता है. हाँ हाँ हाँ, एक्चुअली या यस, Ayush Gupta. So, azeotropic mixture are actually a non-ideal solution, of course. They have the same composition in both liquid phase and vapor phase, and also they boil together. Azeotropic mixture is a mixture boiled together. Boiling means converting liquid phase into the vapor phase, है ना? So, actually the composition in liquid phase and vapor phase is same. So, I just want to say here, okay, This is the one where you have liquid A and liquid B and the vapors of B, and this is vapors of A. So I just want to say this is a mole fraction of A and this is a mole fraction of B. This is mole fraction of B in the vapor phase and this is mole fraction of in the vapor phase. I just want to say X is for liquid phase, Y is for vapor phase, right? So you have given the correct interpretation, Ravindra Reddy, at 95.6% of alcohol with 4.4% of water forms an azeotropic mixture. Okay, that graph also I just want to show. So they have the same composition, I mean to say XA is equal to YA. Similarly, XB is equal to YB. The same composition. Actually, liquid phase में ज़्यादा होना चाहिए, vapor phase में कम होना चाहिए, according to the calculation. But for azeotropic mixture, it is going to be the same. They are also said to be constant boiling mixture. They are also said to be constant boiling mixture or azeotropic mixture, or simply say azeotropes. But here, circle 11, hi. But here I just want to let you know one thing. You have two boiling point azeotropes. One is a minimum boiling azeotrope and a maximum boiling azeotrope. You just to take an example that you understand. Minimum boiling azeotrope. So NEET examination और कोई examination में कैसा पूछा जाएगा आपको. So the mixture which show negative deviation is going to form maximum boiling azeotrope. Negative deviation from Raoult law. And minimum boiling, positive deviation from Raoult law. So a trick, my dear students, a trick. उल्टा कर दो, जो भी लिक्विड मिक्सचर है पॉजिटिव है ना, ये मिनिमम होगा. उल्टा पॉजिटिव मिनिमम, नेगेटिव एंड मैक्सिमम होगा. बस इफ यू डोंट अंडरस्टैंड azeotropic मिक्सचर आल्सो ये काम चलने के लिए, बट आई मेक यू टू अंडरस्टैंड. ठीक है बेटा. सो एक्स वाटर इथेनॉल टाइप ऑफ azeotropic mixture, right? Or my answers are correct? Yes, absolutely your statements are correct, Ravindra Reddy. एक बार स्नैपशॉट ले लो सब. 3, 2, 1 ले लिया. हाँ, yes, great. हाँ, now you just see here minimum boiling azeotrope, ethanol and water mixture shows a large positive deviation. Actually ethanol and water shows negative deviation or a positive deviation. Actually it is going to show negative deviation. So that large positive deviation from Raoult law. Okay, large positive deviation, because the graph comes like this now, and they form minimum boiling azeotrope. Minimum, हाँ, शुक्बिडी है क्या you written something, circle 11. Okay, let's talk about minimum boiling azeotrope at certain composition. जो composition Ravindra Reddy दिया गया, you just see this is a positive deviation from Raoult law. So a liquid between the ethanol 95.6% of ethanol, and you have the rest of the composition, this point Actually, the boiling point of water, ethanol 0% and water 100%. Water boils at 100 degree. And ethanol boils at 78.5 degrees centigrade. When you take ethanol plus water, the total mixture boils at 78.2 degrees centigrade. This is, it is an alcohol, Ravindra Reddy. It is alcohol. Ethanol means it is an alcohol, right? So, it is supposed to be a 78.5, okay. So, 78.5 and 78.2, ये वैल्यू से ये वैल्यू कम है, ये वैल्यू से ये वैल्यू कम है. So, that this is minimum boiling azeotrope, you understand? You need not have to understand the graph, why it comes as a leaf. This is the composition mixture, okay. Actually, it is not there in the NCERT. It is not required for NEET or any kind of examination, but composition is important. You need not have to memorize the composition. Yes, you need not have to memorize the composition as well. So, talking about the maximum boiling azeotrope, so nitric acid and water show a large negative deviation, nitric acid and water, so it shows negative, so that it is going to be the maximum boiling azeotrope. At the composition, you see water boiling point is 100 degrees centigrade, you need not have to memorize any value as said, okay. Boiling point of HNO3 is going to be 86 degrees centigrade, but when you mix HNO3 and H2O at certain concentration, 68% of nitric acid, it is going to boil at 120 degrees centigrade. So, then this value and this value बढ़ गया, so that is said to be a maximum boiling point. They are, if you boil at 120 degrees centigrade, you are going to get a vapor. In that vapor, both HNO3 and H2O both will be there together, right? So, it is called constant boiling azeotropes. Clear? Children, you all understood this. So, now the vapor pressure, जब रविंद्र पूछेगा ना क्वेश्चन आता है. So, the vapor pressure of two liquids P, Q are 80 torr and 60 torr respectively. The total pressure obtained by mixing of 3 moles of P and 2 moles of Q. कौन करना चाहता हूं, आप करेंगे या मैं करना? एक मिनट देना चाहता हूं आपको, तुरंत आंसर बता देना. No need to hurry. Put your answer some option in the chat box. D. Firoz, you said D. Okay. Next. Ravinder, मैं करना? हाँ. Look at here. Vapor pressure of two liquids P and Q. P naught Q and P naught Q are 80 and 60 torr respectively. A torr क्या? 1 torr is equal to 1 mmHg. ख्याल में रखो. 4 is 100%. Okay, the total vapor pressure obtained by आपका पूछा गया PS, ये कितना होगा? So आप कर सकते हैं. PS is equal to P naught A mole fraction of A P naught B मोल फ्रैक्शन ऑफ B, राइट. इसका मोल फ्रैक्शन क्या है? इसका मोल फ्रैक्शन क्या? 3 moles of P and 2 moles of Q. कोई प्रॉब्लम नहीं. 3/5, 2/5. So that it is going to be 80 into 3/5 plus 60 into 2/5. कितना आया? This is your answer. Got it? Answer? इशिता? Fine. Fine. और कोई है क्या? Doubts? Firoz? Okay. Ayush? Fine. So, if you do so, you will get the same 72 torque. That's what it is explained in the solution. Right? Clear? Clear? That's good. और एक है. So like these questions only, simple questions, 100% correct. Ravindra Reddy, 100% correct. Now, the system that forms maximum boiling azeotrope. Come on, the system that shows maximum boiling azeotrope. कौन देगा आंसर? जो सॉल्यूशन ये मैक्सिमम करने के लिए नेगेटिव डिविएशन चाहिए. वी रिक्वायर नेगेटिव डिविएशन फ्रॉम राउल्ट लॉ, है ना? सो व्हिच शोज नेगेटिव डिविएशन फ्रॉम राउल्ट लॉ? वेयर इंटरमॉलिक्यूलर फोर्स, जहां पर इंटरमॉलिक्यूलर फोर्स बढ़ रहा है वो नेगेटिव डिविएशन होगा ना, राइट? So it is negative deviation, ideal, benzene toluene ideal, azeotropic mixture for your information ये नॉन आइडियल होना चाहिए. कार्बन डाइसल्फाइड एसीटोन इट इज ए पॉजिटिव डिविएशन. आपका आंसर आएगा. सो इट इज गोइंग टू बी आंसर 1. आंसर 1. आप लोग सही कर रहे हैं. ग्रेट. फिरोज, you just give the answer nicely and silently. Congratulations. Okay, very good, very good. Now और एक क्वेश्चन है. Okay, yes. So a solution contain hydrocarbon A and B. The ratio of in the ratio of 2:3. The vapor pressure of pure hydrocarbon at 25 degrees centigrade at 300 and 100 mm Hg respectively, mole fraction of B in the vapor phase. कौन करना चाहता हूँ? You already solved, Ravinder. Okay. You are such a speed and sharp. Okay, जीते रहो बेटा. God bless you. और बाकी लोग करने दो यार. Just I am looking at the chat box and I am interacting with the guys. Yes. That's good. You have hydrocarbon, some hydrocarbon, and it also present. Okay. A solution contain hydrocarbon A and hydrocarbon B in the ratio of 2:3. The vapor pressure of the pure hydrocarbon is 300 and 100. Okay, the mole fraction of B. So it is given as 2:3. So you can take in the mole fraction also in the same ratio. You can see this is एक हाइड्रोकार्बन A होगा, and ये B होगा. Okay, in this it is given as 300 and okay, ये गलत दिया. Okay, it is given as 300 and 100. You can make it as 2:3. Okay, 2 upon 5, 3 upon 5. Okay, you can take it as a 300, galat type kiya. Okay, you can take 100, you can take 2 is to 3 not 2 by 5 and it is going to be 3 by 5. On solution you are going to get the same manipulated version 0.478 will come. Okay. Now solutions, if a non-volatile solutions of a solid in liquid is very important. It is very important. I just want to discuss what happen if a non-volatile solute is added. Look at this. This is pure water. This is pure water. In this pure water, you have to understand the evaporation process. This is a pure liquid. These are the liquid molecules exhibited on the surface. A lid is placed. So according to kinetic theory, carefully you see, these molecules are in random zigzag motion. So when this make a collision, it is going to be evaporated. When this make a collision, this is going to be evaporated like this. So evaporation takes place in that way. Are you able to understand? So that evaporating molecules tendency is more, so that you will be having the vapors like this. Right? So this is what you call it as a pure solution. Pure solution. I just want to say this is pure liquid ka molecule. If you want to add some non-volatile solute in it, if non-volatile solute is added, some non-volatile solute is added, what happens? Let us see the same diagram. Some non-volatile solute means this is a non-volatile solute. Ishita, can you see the red dots? This is a non-volatile solute. This is volatile liquid. Yes. Now carefully you observe the trick. When this molecule make a collision, it is evaporating. It is evaporating. When this molecule make a collision here, red is a non-volatile, means it do not leave the liquid phase. So that collision do not give the evaporation. As a result of this, बस यहाँ पर जो you can see यहाँ पर वेपर ज़्यादा है, यहाँ पर वेपर्स बहुत कम है. So that it is said to be pure solution का, okay, this is pure liquid and solution. I just want to say pure solvent का. So it is said to be P naught is vapor pressure of pure solvent and PS is said to be vapor pressure of solution containing non-volatile solute in it, right? So उसमें नॉन वॉलेटाइल सॉल्यूशन घुसा है तो क्या होगा, वेपर प्रेशर इंक्रीज्ड और डिक्रीज्ड, यू टेल मी इन द चैट बॉक्स, वेपर प्रेशर क्या दिख रहे हैं, इंक्रीज्ड और डिक्रीज्ड, आई वांट टू नो इट इज इंक्रीज्ड और डिक्रीज्ड, क्या दिख रहे हैं आप बोलना, हाँ यस, it is decreased, so that the decrease in vapor pressure I can say lowering of vapor pressure it is given as P naught minus PS. So you can say lowering of vapor pressure, that is delta P is equal to P naught minus PS, that's it. That is the behavior of the non-volatile solute. That is the behavior of the non-volatile solute. If you could able to understand, you will understand total colligative properties. Because total colligative properties are related to the vapor pressure only. I can clear this, my dear children. I can clear this. Samuel, hi, great. That's what it is shown here. So Raoult law for that, it is given as, we know that Pa is directly mole fraction of A, Pa is equal to Ka. When the pure solvent is taken, mole fraction of A is okay, 1, then K is equal to P naught A, vapor pressure of pure solvent. On substituting the values of K, this equation is got to be Pa is equal to P naught A mole fraction of A, that is equal to 1 minus mole fraction of B. So 1 minus P naught A upon Pa upon P naught A is equal to 1 minus mole fraction of A. So you can say again mole fraction of A plus mole fraction of B is equal to 1. I just want to say a derivation of the total relative lowering of vapor pressure. I just want to say we know that P naught is equal to vapor pressure of pure solvent, PS is equal to vapor pressure of solution containing non-volatile solute. So Rashmita, NEET topic is not discussed in this platform. This platform is mainly intended to do better in NEET 2025. Okay, so ये रीनीट है, होगा नहीं होगा, कब होगा, कौन करेगा, सो वो डिस्कशन करने का ये प्लेटफॉर्म अच्छा प्लेटफॉर्म नहीं है. आई एम नॉट गोइंग टू पार्टिसिपेट इन दैट. ओके, सो आई रिक्वेस्ट माय स्टूडेंट्स, ऐसा मत सोचना, क्योंकि नथिंग इज देयर इन आवर हैंड. वी आर जस्ट टेकिंग द इंफॉर्मेशन फ्रॉम WhatsApp, Instagram, newspaper and news channels, that's it. Assume WhatsApp is not there, Instagram is not there, newspaper is not there, TV channels are not there. So you will be the happiest person, right? So जो भी हुआ अभी तक नीट में होने दो, आगे नीट 2025 का हम क्या करना, ये सोचने का ये प्लेटफॉर्म तैयार है. सर रश्मिता, Okay, try to understand. There are certain sensitive things we shouldn't touch. Samuel, fine beta. Talking about lowering of vapor pressure. इसमें ये डिफरेंस है is equal to P naught minus PS. So I just want to discuss about किस relative का lowering कर रहा है. So solvent का relative में lowering कर रहा है. So that relative lowering of vapor pressure, that is said to be RLVP. That is said to be RLVP, relative lowering of vapor pressure. जो vapor pressure है ना P naught minus PS किस relative में, P naught का relative में, that is called relative lowering of vapor pressure. ये मोल फ्रैक्शन ऑफ सोल्यूट का बराबर होता है. दिस इज व्हाट यू कॉल इट एज राउल्ट लॉ फॉर a solution containing non-volatile solute. This is the actual derivation for this. Okay, so we don't need the derivation. So relative lowering of vapor pressure is equal to mole fraction of सोल्यूट. बस काफ़ी है. सो इस चीज़ से हम मॉलिक्यूलर मास भी निकाल सकते हैं बेटा. कैसे निकाल सकते हैं? सो दैट P naught minus PS, sorry PS minus P naught is equal to mole fraction of solute. This is the one. From here, for a very dilute solution, NB इग्नोर कर सकते हैं. Therefore, P naught minus PS upon P naught is equal to NB upon Na. So from here you can calculate molecular mass. This is the molecular mass of the solute. So this molecular mass of solute can be calculated. It is one of the Raoult law. This is one of the colligative properties also. So let us start with colligative properties. Limitations of Raoult law. Any colligative property or any Raoult law, it is only applicable for very dilute solutions only, and the solute should be non-volatile. This is very, very important. And the solutions containing solute which undergo neither dissociation or association, but this always happens. That's why want half factor आपको introduce किया जाएगा. A last topic of this particular chapter. So let's talk about colligative properties. What are colligative properties? The properties of dilute solutions containing non-volatile solute depend on how much or how many number of moles of solute present in the solution, but not on the chemical nature of the solute. Such properties are called colligative properties. So the properties of solution which depend on number of particles or number of moles, okay, of solute irrespective of their chemical nature are called colligative properties, and the solute supposed to be non-volatile. That's very, very important. The solute supposed to be non-volatile. So these colligative properties, only four colligative properties: relative lowering of vapor pressure, elevation of boiling point, depression in freezing point, and osmotic pressure. Relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. I just want to mention one thing here, my dear students. रिलेटिव लॉवरिंग ऑफ वेपर प्रेशर कॉलिगेटिव प्रॉपर्टी होगा, लेकिन लोअरिंग ऑफ वेपर प्रेशर कॉलिगेटिव प्रॉपर्टी नहीं होगा। एलिवेशन इन द बॉइलिंग पॉइंट कॉलिगेटिव प्रॉपर्टी होगा, लेकिन बॉइलिंग पॉइंट, खाली बॉइलिंग पॉइंट कॉलिगेटिव प्रॉपर्टी नहीं होगा। सिमिलरली डिप्रेशन इन फ्रीजिंग पॉइंट कॉलिगेटिव प्रॉपर्टी होगा। सो ये फ्रीजिंग पॉइंट, खाली फ्रीजिंग पॉइंट अकेले कॉलिगेटिव प्रॉपर्टी नहीं होगा। ऑस्मोटिक प्रेशर कॉलिगेटिव प्रॉपर्टी होता है, ऑस्मोसिस नहीं होगा। So which of the following is not a colligative property, which of the following is a colligative property, ऐसे क्वेश्चन पूछने का संभावना है। So Rashmita, are you there? Right, let's talk about relative lowering of vapor pressure. We discussed it already, right? And talking about elevation in boiling point. What is this elevation in boiling point? So let's talk about a graph, boiling point का graph, vapor pressure का graph। Vapor pressure and the temperature. If you take a solvent, this is your solvent. Right? If you take a solution containing non-volatile solute in it, इसका वेपर प्रेशर सॉल्वेंट के कम होगा, ज़्यादा होगा बोलना? हमेशा वेपर प्रेशर कम होता है। This is solution, right? Now if you take a 1 atm pressure, जब वेपर प्रेशर 1 atm होगा तब ये solution boil करने का संभावना है। So the boiling point is the temperature where the vapor pressure of a liquid become atmospheric pressure, that is 1 atm, right? So this is the temperature, this is the temperature, right? So this temperature you can see, this is the temperature of the boiling of pure solvent, and this is the temperature of boiling for the solution. And ये जो अंतर है ना, that is called increment in the boiling point. Increment in the boiling point, that is called increment or elevation in the boiling point. So I just want to discuss here, T naught B is boiling point of pure liquid or a pure solvent. Here it is, TBS is the boiling point of solution containing non-volatile solute. Delta TB is equal to TBS minus TB naught, that is called elevation in boiling point. This is elevation in boiling point, EBP. Ishita, fine? So this elevation in boiling point is a colligative property. So it's said to be delta TB is directly proportional to molality. So delta TB is equal to KB into molality. ये KB है Ubilioscopic constant, that is molal elevation constant. We are going to discuss about that. When molality is equal to 1, KB is equal to TB. So a molal elevation constant is otherwise called Ubilioscopic constant. This Ubilioscopic constant is defined as the elevation in boiling point when 1 mole of the solute is dissolved in a kg of solvent. Fine. This is how definition के हिसाब से भी बोल सकते हैं. So let us talk about the elevation boiling point. This is the overall picture about the elevation in boiling point. समझ में आ रहा है क्या? So from here you can calculate the molecular mass as well. Okay, molality का formula बता डालो. You can say delta TB is equal to KB into molality का WB by MB into 1000 by WA. From this you can calculate molecular mass of the solute. I am telling you what is the main use of the colligative properties, to calculate the molecular mass of the solute. Okay. So this is what the graph, little clumsy, so that I just want to draw from my side. Clear? Fine, children? Okay. So Ravinder kaha gaya? Satyam, you gave answer and you forgot me. Okay, Samuel Tasfu. Ravinder kaha gaya? Let's talk about the more details. Yes, these are all discussed, right? Let's go into the details of the ebullioscopic constant, or KB, ebullioscopic constant. Or you can also say this is molar elevation constant. KB is thermodynamically shown as RTB square upon 1000 LV. Here R is a gas constant. Here यहाँ पर लिखा हुआ. And TB is the boiling point temperature of the liquid solvent. LV is latent heat of evaporation, physics. Or otherwise mRTB square upon 1000 delta H vapor. Here M is the molecular mass of the solvent and delta H vap means enthalpy of evaporation of the solvent. So these two expressions are काफ़ी important है KB का वजह से, because in the NEET examination MCQ पूछा जाएगा आपका. ठीक है? Right, my dear students? Clear? Any doubt? Any doubt? Now depression and freezing point. In this depression and freezing point is, you can see, just a quick recap for here. Vapor pressure, हर colligative properties vapor pressure में depend किया जाएगा. So if it is a solvent, it comes like this. Okay. This is for solvent and it is for solution. Now you can see this one. What is the curve here? This is in the liquid state. This is in the solid state. The liquid become a solid now. This is the transition point. That transition point is what you call it as freezing point of the solvent, and this transition point you can say freezing point of the solution. Okay. So there is a decrease in the freezing point. Let us say water freezes at 0 degree centigrade. If we add a little bit of salt, उसमें कुछ नमक डालने तो water freeze हो जाएगा -2, -3 like that. Okay, so that you can say delta TF naught is a freezing point of solvent, pure solvent. TF yes is freezing point of the solution. So there is a decrease in the freezing point. You can say it is a depression in freezing point. depression in freezing point delta Tf, you can say Tf naught minus Tfs. So, depression in freezing point is a colligative property. So, that delta Tf is equal directly proportional to molality. Delta Tf is equal to Kf dot molality. Kf is called molar depression constant. Or is also called as, dear students, cryoscopic constant. Kept quiet in the chat box. Why? What happened to you guys? Ishita? So, this, if molality is 1, then Tf is, delta Tf is going to be Kf. Okay, that is calculated. You can also calculate molecular mass from the molality. That's what it is mentioned here. Yes, delta Tf you can calculate from molality directly expose kiya. Okay, right. Now, अरे कुछ thumbs up देना यार. Rashmita and Satyam and Samuel, many students are there. Ravinder, where are you? Only Ishita is there in the class or what? Okay. Now, osmotic pressure will come back in the next session better. So, Kf you can calculate by using R T naught square upon 1000 LF. So, latent heat of evaporation here, freezing, and enthalpy of freezing. Yes, Pranav Balaji, I didn't see you आज आहे class में. Okay, अभी तक good afternoon नहीं बोले आप. Okay, so in today's class we just recaptured vapor pressure and Raoult law, positive deviation, negative deviation, azeotropic mixture, and colligative properties. We started good presentation, Abdul Rahman. That's good. And we discussed elevation in boiling point and depression in freezing point. Okay, relative lowering of vapor pressure भी किया गया. Okay, and सिर्फ osmotic pressure बचा है. So अगले क्लास में आप osmotic pressure want of factor का देखना पड़ता है. Okay, today we are done with the class. So thank you very much for your all cooperation. So I request my dear students, you please like the session and share and subscribe. We'll meet with more stuff in again hydrocarbons in Monday session. Don't forget. Okay, thank you very much. God bless you. Say bye. Bye bye.